In this video, we'll look at the greatest common factor method for factoring polynomials. Let's take a look at some examples. Consider the following expression, 3x plus 3y. When we factor this expression using the greatest common factor method, the factored form will look like this. It'll be the greatest common factor, abbreviated as GCF, multiplied by an expression that contains the same number of terms as our original expression, in this case, 2 terms. We can find our GCF by identifying the greatest common numerical factor and the greatest common variable factor. Observe that both terms of our expression have the coefficient 3. That means our greatest common numerical factor is the number 3. However, since our 2 terms have different variables, there is no common variable factor. As a result, our GCF is simply the number 3. And let's put that in. To fill in the parentheses, we can divide each of the original terms of our expression by the GCF. Dividing the first term, 3x, by 3 causes the 3's to cancel, leaving us with just an x. Similarly, dividing the second term by 3 causes the 3's to cancel, leaving us with positive y. Thus our factored form is 3 times the quantity x plus y. Let's increase the difficulty a little bit. Consider this expression, 6x squared minus 15x. Once again, we want to find the GCF and factor our expression into the following form. GCF times an expression that contains 2 terms. Again, 2 terms because our original expression has 2 terms. Once again, we're going to build our GCF by finding the greatest common numerical factor and the greatest common variable factor. Let's find the greatest common numerical factor by looking at the coefficients of each term, 6 and 15. I like to start with the smaller number and find some possible factorizations. 6 is 1 times 6, and also 2 times 3. And we can look at these factors and decide which one will also go into 15, and which one is the greatest that goes into 15. 1 and 3 both go into 15, but 3 is the largest of the 2. So 3 is the greatest common numerical factor. For our variable factor, we can see that both of our terms have the variable x. The first term has an x squared, and the second term has an x. The greatest common variable factor will simply be the smallest power of the shared variable. In this case, it would be this x to the first power. Putting these two together, we can see that the GCF is 3x. Let's write that in below. Now, to fill in the parentheses, we need to divide each of the original terms by the GCF. The first term, 6x squared divided by 3x, will become 6 divided by 3 is 2, x squared divided by x is x. The second term is negative 15x, and when we divide that by 3x, we get negative 15 divided by 3 is negative 5. X divided by x cancels out completely, so it's just negative 5. And that's it. 6x squared minus 15x is equal to 3x times the quantity 2x minus 5. All right, let's work through one last problem. 30x to the 9th y squared minus 12x cubed y to the 4th plus 20x y squared. This time our expression has 3 terms, so our final factor form will look like this. Our GCF multiplied by a quantity containing 3 terms. Let's build our GCF starting with the greatest common numerical factor. Our 3 terms have the coefficients 30, 12, and 20. And we're trying to find a number that divides into all 3 evenly. I'll factor the smaller of the 3 numbers and try to identify the largest of those factors that divides evenly into the other 2 numbers. Factors of 12 include 1 and 12, 2 and 6, 3 and 4. 12 does not divide evenly into 30. 6 divides evenly into 30 but not 20. 4 divides evenly into 20 but not 30. 3 divides evenly into 30 but not 20. 2 divides evenly into both numbers. So 2 will be our greatest common numerical factor. Now let's write the variables for each term. The first has x to the 9th y squared. The second is x cubed y to the 4th. And the third is x y squared. X is in common to all three terms, so we'll choose the factor with the lowest power, this lone x. Y is also in common to all three terms, and there's a tie for the lowest power. It's the y squared. I'll choose this one. Putting the two together, our greatest common variable factor is x y squared. Altogether then, our GCF is 2xy squared. And we can fill that in below. Now we'll find each term in the parentheses by dividing the original terms by our GCF. The first is 30x to the 9th y squared divided by 2xy squared. 30 divided by 2 is 15. X to the 9th divided by x is x to the 8th. And y squared divided by y squared cancels completely. When we divide the second term, negative 12x cubed y to the 4th, by 2xy squared, we get negative 12 divided by 2 is negative 6. X cubed divided by x is x squared. And y to the 4th divided by y squared is y squared. And finally, the third term, 20xy squared, divided by our GCF 2xy squared. Well, positive 20 divided by 2 is positive 10. X divided by x cancels completely, and y squared divided by y squared also cancels completely. Therefore, our final factored form is 2xy squared times the quantity 15x to the 8th minus 6x squared y squared plus 10.